Okay, so we're going to just chat a little bit about our overview, and I'm going to ask you guys a little bit about what you know about IoT. I'm not going to put you on the spot, just kind of size up who's here and kind of why they're here and things like that. Um, and how do you start? Particularly if you're just starting out or you want to get into it, or maybe you have some of the pieces of the puzzle, uh, kind of sizing up and making you aware of where you're at. I'm not going to ask everyone where you're at on this journey because you'll be building this. And then if you haven't started anything, how do you start? And pretty much these recommendations come for almost any of these endeavors that are new. You want to start small and grow from there. And then with any good endeavor dealing with maintenance and reliability, you need to be on a reliability roadmap. And that's not a huge, heady thing that's difficult to get into. It may be presented that way, just like IoT may look like something huge. But we're going to talk about that. It's not as bad as you may think. And then some ways to enter in IT-like things. IT is not the answer, it's part of the puzzle. And then we'll talk about some strategies to move along the journey. So how many of you feel that you actually have some IoT things going on in your company today? Okay, a few, that's good. How many have attended other sessions more specific on IoT and some of the technology while you were here? Okay, good as well. I did. There's some really, really good stuff happening, right? It's getting a lot easier. How many of you are very apprehensive and kind of afraid of IoT? Like, oh, this is this big thing I can't take on. Anybody? Okay, good. You're brave. That's great. Okay, so let's chat about this a little bit. I'm sorry I've been talking too much, and I'm a little bit raspy. See if I can get this to go. There we go. All right, so I won't dwell on this too much, but when you get presented with IoT and you never really had a definition before, and you may see pictures like this that look very daunting and something that's unachievable, too big to take on, and just no way I can do this here, or I'll never get my executives to understand this and buy into it. But it is part of the picture, so sometimes you see that it's a huge undertaking, and it's like boiling the ocean and things like that, and you just can't get into it. But it doesn't have to be that way. And so we'll see some examples of this. And again, if you do try to take on the whole thing, then it may be unachievable for you, particularly at one time. And of course, it doesn't necessarily apply to everything. And so we'll be dwelling on that in just a moment, if I can get this to go in the right direction. So with any of these type activities, and I'm really glad that you're here, because this is not only a Maximo conference, but it's also a reliability conference. So it's sponsored by Reliability Web. They interject those philosophies and thoughts into everything they do, and we've learned a lot from them. A great collaboration between our company and their group. Some of them were previous clients of mine, which is really cool, and we learned things together. But you always want to be on some kind of roadmap, or you could fundamentally say you need to have a plan, right? You don't just apply a lot of technology without a plan. And so here's some pictures. These are similar to other pictures that are out there. Don't try to read it here. You can look at the PowerPoint later. But if you look at diagrams like this over here, if I can point to this, the periodic chart with the fundamentals and the pillars of reliability, that's baked into these, baked into these diagrams. There's a lot of different versions of this. But what they all do is they say you need to start with the fundamentals. And in this case, make sure you have your assets identified that you're trying to take care of. And you hear a lot of words here about asset health, asset sustainability, and it's all talking about how do I take care of my assets to make them produce more. A lot of you are in different industries, so your product is different, whether it's power or whether it's municipalities or whether it's some kind of manufacturing. So the first thing is identify what you're taking care of, and then also consider getting on what's commonly called a maturity continuum. Where are you on your maintenance curve? Are you mostly reactive? Are you moving toward more preventive, proactive and predictive moving up. So there's different versions of this picture, so I don't want you to try to read that either. Again, these are related to pillars of reliability. and some of you will be doing some of those really well, and some of you will be doing certain things not so well. And you need to know where you're at with that before you add more technology to the mix. So just kind of awareness there. And let's see if I can get it to go in the right direction. Then the next step is to prioritize your assets. So for those of you who have gone through these exercises, there's asset criticality ranking. Some people call them ranking your assets by importance. Like if this asset goes down, I'm no longer able to make widgets at my factory. I'm losing money, losing revenue. That's more important than, let's say, a storm drain out in the parking lot that has a sump pump, things like that. Just being realistic about what's more important and what's less important. And don't apply your technology dollars evenly across the board. So it sounds very simple, but not everybody's thinking this way. So you're going to go and identify what's important, what's your bad actors, and you're going to focus on those first. Because what are your executives looking at? Pain points, right? I need this money. Well, what am I going to get for this money? Well, we're going to fix this compressor that's always going down and taking half the plant down, right? Things like that, as opposed to we're just going to put IoT on everything, right? Just spread a wide net. So here's another example, another viewpoint of a roadmap. So you're starting at the very beginning. You should have at least a fundamental description of how you're going to care for your assets, and again, ranking them. If you haven't considered having an asset management plan, an AMP, it doesn't have to be a complicated document, but it's saying, here's how we're going to take care of our assets, and we're not treating them all the same. And it also goes into things like what detail you're storing about your assets. And it also can spin off into other areas such as the supporting parts and labor and skill sets and things of that nature. But during that process, when you identify your critical assets, you're going to identify how to take care of those assets. What information do I need to know to tell if that asset is healthy or not? And some people are using the word sustainability plan, which is okay. And so some information that you might need to tell that asset is healthy is readily available. Some of them are not. And so if they're not available, then you need to try to find some way to get that information. And that's where technologies like IoT come in, because if you have no source for that information, you go out and put a sensor on something or an interface to some other system that may have that piece of information that you're looking for. How many of you have ever gone through an exercise? How many of you know what an FMEA is? FMEA, failure modes in effect? Good. 5 years ago, it wouldn't have been as many hands. How does something thrive? How does something fail? And what will tell me whether that's happening or not? So that's where you start. You don't just canvas everything and put sensors and collect data off of everything. So this is a progression where, okay, we don't know the condition of our assets, so they fail, and when they fail, we fix them. Moving all the way up to where we've been monitoring this asset. We know that it's got about 3 more months before it is likely to fail. And depending on the importance, you'll take different actions. And eventually, you know within a pretty tight window of time or condition that this is going to fail. And again, if it's more important, then you're going to take different actions. And you build that into your system designs as well, redundancies and different things that you do. Okay? So, a lot of companies have data available to them. They just don't realize it. So you notice I put IoT in quotes, so it doesn't necessarily have to be a dedicated sensor out there that you placed on a machine. It may be something that's already being collected by some other system or by the asset itself. More and more assets are smart assets. I know it was funny, Terry in his opening keynote said dumb assets, and none of us heard it correctly, right? So anyway, most assets are dumb assets, but there are a lot of ways of monitoring a good many assets remotely or without putting a sensor. So for example, electric motors and things like that, there's a lot of technology that you can actually monitor them from the motor control centers and various other places and tell a lot of health information about those assets without installing a sensor. And then, of course, there's assets that are monitoring themselves. The red light comes on for a reason. Your check engine light in your car is an example of that. It's got lots of monitoring going on. And then you just need to learn how to access them, right? Now be creative. Okay, somebody's already collecting that piece of data. Maybe not in the form that they expected, but it's useful for maintenance. Some of this is operational type data, maybe even throughput, different variables that are used for operation that may factor into that. So what do you do if you don't have these sensors? Again, you go out, if you don't have these data, then you may have to install some sensors. So I'll go through that exercise first, because we have seen companies that blanketed the plant, put in sensors everywhere, and found out that half of them are already being recorded in another system. And again, as Terry and IBM and several people this week have talked about doing a function one time and not doing it 3 times redundantly and maybe colliding with each other. So try to be smart about it. Again, you're hearing me talking about be creative and size up your situation. Have a plan before you start, hiring people to put in sensors everywhere. Okay? All right, so just realize you may already have some of the data that you're looking for. If you don't, then yeah, figure out a way to get that data. Okay? Now, what's the typical uses for this kind of raw data in Maximo? Here's 2 very fundamental cases that a lot of you hopefully everybody's familiar with. So there's 2 major types of readings in Maximo that could come from an outside source. Some people are doing it inside of Maximo, but this is kind of my term for this. So it's a usage-based meter, like your runtime meters and and continuous meters, things like that. Those are typically used for PMs, meter-based PMs. Okay, now they may be used for other analytics, but they may be used for triggering PMs. And of course, that's usually only a lead up until you actually flip over and start doing more condition. Tell them you're busy. Tell them you're talking to Walter. Anyway, so how many of you are doing meter-based PMs right now, even if it's just 1 or 2? Okay, great. And so that was a major evolution from time-based PMs, right? But you notice that wasn't on here because it's not a data source, right? It's just time. And a lot of times you'll gravitate and those will be replaced or either supplemented by some kind of condition or health monitoring type philosophy. And then of course there's condition-based. And again, just because you're taking a reading doesn't mean that it's using Maximo directly to trigger a PM, but definitely that capability is there. And it's very, very useful. And both of these come in different flavors. But these condition-based readings may be an actual gauge reading, or it could be from a sensor, or it could be from some other system that's taking that reading. But then also, as we talk about a little bit more advanced architectures where you might have another system processing that data, or we use the word pre-processing the data, they may be taking thousands of readings and doing things and then giving you the results of reading all those readings and then sending that to the EAM. So that's also common. And you could call that a condition. In other words, you may have dozens of readings on this complex machine, and you have another system that analyzes all that and then sends you a health score, for example. So it's a resultant, it's not raw data, it's something pre-processed with rules and algorithms, possibly AI. We'll talk about things like AI just a little bit, because one thing you need to do is figure out what's normal for that machine. Don't necessarily say what the manufacturer says is normal, like this motor is okay until you hit 100 amps and it trips the breaker, then you're not okay. Well, most of us know that you don't wait till you trip the breaker if that motor normally runs at 40 amps and now it's consistently pulling 50 and 60, that's not normal. But it's not out of range for the manufacturer, right? It hadn't tripped the breaker yet, but it's not normal, so you need to track it ahead of time. So different kinds of readings. How many of you are using condition-based readings? Okay, good. And of course, you apply that appropriately. You don't just apply it on everything, but it is a typical migration going from time-based to usage-based to more of a condition-based. You'll always have a mixture, but you'll slowly shift over. So again, these readings could be from another system, or you may have to put in a sensor, or it may be something you still capture manually, hopefully with some kind of mobile device, something that's easy and fast. Okay, so here's some evolutions, if you will, for putting in IoT or doing IoT type things with Maximo. So if nothing else, so again, you go through the exercise of identifying what data points will tell me if this particular asset is healthy. You know, again, you identify your assets, you prioritize them. Typically, your top 20% assets are the ones you're going to focus on. You know, it's a gradient scale. And then you determine what data points are going to tell you whether that's healthy or not, doing the reliability analysis. So if you cannot get that information, or if you cannot do it in the short term, then you can manually collect it, which is, you know, nothing wrong with it. It's just, it's more effort, right? And takes longer, and there's human interaction, and data quality may be an issue depending on how you're collecting it, things like that. And then the next evolution would be some kind of electronic transfer of information from some source. And if it's directly fed into Maximo from, let's say, a sensor that's taking readings twice a second, sometimes more than twice a second, that's a lot of readings coming in Maximo. Now, Maximo can handle it, but it's not really efficient, right? You're going to fill up tables and things like that, and queries will be slower. And we'll talk about that in a second. But you could feed in tens of thousands of readings, you know, feeding into Maximo for hundreds of pieces of equipment, multiple readings per equipment. Ends up being a lot of readings, right? But you could. But typically, you're going to want to do some kind of pre-processing. So inside of Maximo, there's various techniques that you could do. And when I say pre-processing, let's say that you're taking, I hadn't done the math on this, but anyhow, let's say it's about 5,000 readings per day from one sensor. You don't really need that in Maximo, but what you typically need is what's the high and the low and the average, things like that. So depending on the piece of information, you might want different things. So you end up with 3 or 4 readings, a high, a low, and an average, for example, maybe a spike, and instead of 5,000 readings. Does that make sense? And you could do that either with something through the interface technology or automation scripts, various ways you could do it with the configuration abilities of Maximo, processing those 3 through. And if you keep it relatively simple, then you can design that for all your sensor readings that you're doing this way. I would see that as a short-term solution, you know, maybe a couple of years. I would move to the next level that we'll be talking about right now. So typically, if you get into this in a little more evolved definition, then you're going to have some kind of system that's monitoring assets. I call them asset monitoring systems. How many of you have OSI Pi? It's pretty popular. It's very strong. How many of you have ThingWorx? Okay, great. How many of you ever heard of IDIS Digital? Are they here, Chad? I can't remember. Anyhow, they're a little bit more on the reliability side. They help you do the reliability studies, but they can also take in readings and do things with them before it goes on to some other destination, you know, such as Maximo. And of course, there's definitely the IBM solutions on the cloud, you know, the monitor and the predict, those kinds of things. They can take the readings, do things with them, and not only analyze them, but also package them for another destination, kind of a leapfrog, if you will. And so when you get to that point, you've got a lot of things going on. You've got more ability to monitor to tell when this particular asset is not healthy, or you can even analyze collections of assets that are working together to perform a function. And you also can have other inputs, such as the output of your process. So if your factory is cranking out, let's just say 100 widgets a day, and you've got a lot of orders, and you're going to push the factory, and we're going to go 10% over, and we know we can do that for a period of time, you know that all your maintenance readings, your monitors, are going to be high. Your electricity usage is high, amperage, load on the machines, that varies depending on what you're doing. And so you may go over some of your normal alerts. So you can actually trim those, if you will, modify those alert values based on your performance of your factory, if you will. Just like if you drive your car 40 miles an hour, your temperature is going to be one thing. Drive at 100 miles an hour, probably going to be a little hotter, right? You can take exhaust temperature or whatever. It's going to vary based on load. So you can do those kind of things a lot easier with a system that's designed to do that. And again, very complex modeling. Any inputs you have coming in, you can design what is the appropriate monitoring and calculations for that type of equipment. Make sense? Now, a lot of you have OSI Pi from an operation standpoint, not from a maintenance standpoint. So it was already there. And so depending on how it was set up, it might be very easy to go and grab certain information from that system and bring it over to Maximo. Or you may have to have the alignment, just like you do with any 2, 3, 4 systems. If you're all talking about the same assets, you've got to have a common naming convention, and this is the same asset in all these different systems. Again, that was mentioned in several sessions here this week as well. Trying to do things one time instead of 3 times and make sure everybody's on the same page, looking at the assets the same way. I will mention that a lot of the big data centers, AWS and Google, and some others are also developing their own capabilities in these areas. They're obviously very strong data centers and scalable sets of virtual architecture, great, but they also have some capabilities in these areas, developing capabilities, so they don't have the history that IBM and these other folks have. Okay, so that's kind of an evolution. Again, you can collect things manually, going up to something kind of in between, and then eventually you're probably going to want to have a system dedicated for monitoring assets. And by the way, not only, I may have already said this, so I apologize, but these systems are not only passing readings through or pre-processing readings, but they may also be passing alerts through. So that system may trigger and say, okay, we've got a problem, we need a service work order to go and take care of that problem. And so it may trigger a work order to be generated in Maximo directly, instead of triggering a condition-based trigger in Maximo. And some of you are already, how many of you are doing that already? You're having an external system triggering a work order in Maximo. Yeah, predefined work order to target that issue. Great. Okay, so this is kind of to summarize a little bit and say it in a little bit different way. First step is always to have a plan, and we strongly recommend having some sort of an asset management plan, which includes listing your assets, having a definition. What is an asset? What is not an asset? What do we call our assets? How do we take care of our assets? And then you rank them and what's important, what's less important. Then you start determining how these assets fail, or how do I know what pieces of information tell me that this asset is healthy or not. And it was interesting. I was on a coast-to-coast plane ride one time, sitting next to a cardiologist, and you wouldn't think having a conversation with a cardiologist would be that interesting, but we were 4 hours on an airplane. There was a little alcohol involved, and he was wearing, and this was probably about 8 years ago, he was wearing real-time sensors on his heart. I mean, he's a cardiologist. He's into the heart thing, so he's got some, electrical sensors on him going to his smartphone. And this is when smartphones, weren't as strong as they are now. And so he's into it. And I said, well, that's pretty cool. That's similar to what we're trying to do with our maintenance in the factory. And he was very fascinated that we're putting sensors and doing similar type things. So the health of your assets follows a parallel path to the health of human beings. You got electrical things that tell you when you're healthy. You got pressure readings that tell you when you're healthy. You have other readings and analysis to tell you when you're healthy. The collection of those, high blood pressure plus this is not good, or maybe it's okay, maybe they balance out. Same thing with machines. Find out what tells you when you're healthy and do it in a prescriptive plan. And then typically you'll do it in a pilot, or either you'll attack your bad actors. This is a problem. And that gives us more bang for the buck, gets more wins so we can do the rest of the program, so we can convince our executives that this is a good thing. And and as you refine your data and get more predictive, at the same time you're refining your maintenance practices. So some of the things that move you to the right on this scale is not just the data and the information, it's your culture. It's your culture on your people. Make sure everybody's pulling the same way. Some companies will have separate reactive maintenance teams from predictive maintenance teams. Sometimes they'll even have a third predictive maintenance team, and they may not be pulling all together. And so they're all going out and touching the asset. And, particularly the condition-based teams, they're heavy in the analytics. They're reading things. It's like, okay, why do we have this spike over here? Well, you had a repair that you didn't know about. And all of a sudden you got this spike, or you got a change. And you think, well, something's happening in that machine. Yeah, another team touched the machine. Or maybe they changed lubricants, or all kinds of stuff, right? And then institute a continuous improvement program along with that. So definitely button down your fundamentals, work execution, everybody pulling in the same direction, and then monitoring how are we doing, where are the gaps, and of course focusing on the priority equipment. Then you start working on the secondary equipment. And some of the equipment you won't go to this effort. It's not worth it. Okay, it's either run to a failure, or it's something that's not contributing to the output of your product. Now the other thing out here, you have graphs like this where you may have high and low ranges, but you're also looking for things that are really odd, anomaly detection. And again, by the time you have a system that's able to analyze these kind of readings, the volume of readings, so if you're not taking readings all the time, you may miss one of these, right? So, and it's really great with the technology that we have today, because you can take readings 24/7, 2 or 3 times a second, and that way you don't miss something that might be important like this. And the other thing that happens, if you're not catching this and the machine fails anyway, you can go back and, well, I'm old school, you can go back and read the tape. It's like black boxes on airplanes. Why did the airplane crash? Well, let's see what the readings were leading up to the crash, right? And you're able to do this kind of thing because you have all the details being stored. Okay, so that's the presentation here. I'm going to open it up. Does anybody have any questions about this? Any experiences that you want to share that might be related to this subject? Everybody good? Was this helpful? Hopefully it was. Again, have a plan, work toward the plan. Don't just make a plan, put it on the shelf. Don't try to boil the ocean and put IoT on everything. We don't need IoT on the coffee maker, okay? I know it's important, but it's not good use of your time, and work toward that plan. And hopefully this was helpful to you. If it was, let me know. And if anybody wants to chat about this further, feel free to come up here. I'd love to help you out. If no questions, going once, twice. Well, thank you for attending. This was a good crowd. I appreciate it.